Revit levels and grids, how they control your entire model. Hello and welcome to our new video. In today's video, we will talk about levels and grids in Revit. These are fundamental reference elements that control how the model behaves, how elements are associated, and how the entire documentation is created. Let's get started. Levels are finite horizontal planes that act as a reference for level-hosted elements, such as roofs, floors, and ceilings. We create a level for each known story or any other required reference of the building, for example, the first floor, top of wall, or bottom of foundation. In Revit, levels are not just heights. They define how elements are hosted, constrained, and documented. To access or activate the Level tool, we need to be in the Architectural tab, where under the Datum tool we can find Level. The same applies in the Structural tab under Datum. The Level tool is also available there. It's important to note that levels cannot be created while we are in a horizontal view, meaning floor plans. To add levels, you must be in a section or elevation view. We'll go to the east elevation and activate the Level tool. We can choose between the Line or Pick Lines option. We'll start with Line. We'll begin from the left side and draw the level line, extending it until it snaps to the existing levels. We can see that a structural plan has appeared in the project browser. When we open it, we see that only Level 3 is present. Additionally, under Floor Plans and Ceiling Plans, Level 3 has been created automatically as well. Here's why that happens. We activate the Level tool again and notice that the Make Plan Views checkbox is enabled. When we click Plan View Types, a dialog opens showing the plan views that will be created when a new level is added. In this case, floor plans, ceiling plans, and structural plans are all selected. Now we'll disable ceiling plans. We continue and create a new level. We can see that this time no corresponding ceiling plan has been created. Next, we'll completely disable the Make Plan Views checkbox and then create another new level. We use this option when a level is needed only as a reference height, but we don't want any additional views to be created in the project browser. We can see that now no plan views have been created at all. Another thing we notice is that the level symbol is black. This indicates that there are currently no plan views associated with this level. If we later decide that we do want a plan view for this level, we go to View, then Plan Views. Here, we can choose between Floor Plan, Ceiling Plan, or Structural Plan. In this case, we select Floor Plan. We then select the level we want. In this case, the only available option is Level 5. Click OK, and a floor plan for Level 5 is created. We can also see that the level color has changed to blue. When we select the level and look at its properties, under Identity Data, we have the option to enable Structural. This option defines whether the level will be recognized and used in structural views and plans. In architectural projects, we often disable this option to maintain a clear distinction between architectural and structural levels. We'll keep it disabled here. When we select Level 5, we can see this line indicating that it is linked to Level 4. We can also see the padlock icon, which means that if we move one of these levels, the other one will move together with it. The other levels did not move because they were not locked to these two. Now let's move them. We can see the snap, and there we go, now they are all aligned together. When we move one of them, the others follow as well. If we want to move only a single level, we select it, then click on the padlock to unlock it from the others, and move it independently. We'll move it back so that it aligns with the rest again. This is especially useful when we want to maintain a consistent floor-to-floor height. Let's zoom in a bit on the level symbol. When a level is selected, we can see a checkbox next to the symbol. In this case, the box is active. This checkbox controls the visibility of the level symbol. If we turn it off, the symbol will disappear. We can enable the symbol on only one side or on both sides. Of course, we can also turn it off again. Next, we can change the level name directly here by clicking on the name. The name can also be changed in the Properties panel. We'll rename it to Second Floor. A dialog window appears asking whether we want to rename the associated views to match the new level name. We'll click Yes. We can see that the name change has been applied to all plan views associated with this level. Let's also change the name of the level below to First Floor. Again, we'll click Yes. We can also change the level height directly here by entering the value we want. We'll enter 7,500. When levels are close to each other and their names start to overlap, we can resolve this in the following way. With the level selected, we can see the Add Elbow icon. We'll click on it and move the elbow so the level names no longer overlap. This is commonly used to avoid visual clutter, especially in dense sections and elevations. A level can also be moved directly using the mouse. If we no longer need the broken or offset level line, we can restore it back to its original straight form like this. Something you've probably already noticed is the 3D indicator at the ends of the levels. Let's first take a look at the 3D view and see how levels appear there. We can also make changes to levels directly in the 3D view. Now, let's go back to the east elevation. When a level is selected, we can see this 3D marker. If we click on it, we switch it to 2D. Now we'll move this level. We'll do the same with the first floor level. When we go back to the 3D view, we can see that nothing has changed. We'll return to the elevation and repeat this for all remaining levels, switching them to 2D. At the location where the 3D marker was, we can now see the circle symbol. Again, in the 3D view, nothing has changed. This clearly shows that 3D extents are global, while 2D extents are view-specific. When a datum is set to use 3D extents, and those extents are modified in one view, the change is applied to all views. When using 2D extents, modifying the extents affects only the current view. If we don't want them to be 2D extents, we select the level. In this case, we will select all of them, then right-click and choose Reset to 3D Extents, and then we will have 3D Extents again. Now, let's take a look at type properties to see what we can modify. We click on a level and then go to Edit Type. The Type Properties window opens. We can see the name of the existing type, but we will create a new one. We click Duplicate and give it the name Levels Example. The first thing we see is Constraints, and we can see that Project Base Point is selected. When we open this menu, we see that Survey Point is also available. Project Base Point is used for internal project heights, levels, floors, and structural heights. It is the most common choice for most architectural projects. Survey Point is used when working with real elevations above sea level, survey data, and coordination with external references. In most architectural projects, Project Base Point is the correct choice, and we will leave it as is. Next, we have Line Weight, and we will change it to 6. Below that is Color, and we will choose Cyan Green. We click Apply, then OK. Let's zoom in a bit and see how it looks. Only this level has changed, and we can see that the others are of a different type. Now we will assign the type we created to all levels. We continue with Type Properties. We click on a level and then Edit. The next item is Line Pattern, so here we can choose what kind of line it will be. Let's choose Dash Dot and click Apply. We can see the changes. Next is Symbol. When we open the menu, we see the available options within our file. First None, then Circle, which is our current symbol, and finally No Bubble. If we select No Bubble and click Apply, we can see how it looks. However, we can also load additional symbols. First, we will click OK to close the window, and then go to Insert, then Load Family. We choose Annotations and go to the letter L levels. When we click on them, we can see how they look in the preview. We will select Triangle and click Open. Now we click on a level and then Edit. Under Symbol, we can now see the type that we loaded a moment ago. We will select it and click Apply. The choice of symbol is primarily a matter of office standards and drawing readability. The next option is whether we want to have a symbol on one end and, for example, turn it off on the other end. We will return it to how it was. We click OK. One more note, it is important to know that the symbol size automatically adjusts to the view scale, which means that the same level can look different depending on the scale. Now let's show a few more things once we have an object in the model. At the very beginning, we mentioned that floors, roofs, and walls are associated with levels. For example, with this wall we can see that it is defined with level 1 as the base constraint and level 2 as the top constraint. Also doors, chairs, everything is associated with a level. When we want to move a level, for example to a height of 300, we can see that everything associated with that level moves together with the level. Now we type 270. Now we will return it to 280. Also, if we delete a level, everything associated with it gets deleted. First, we get a warning showing what will be deleted along with this level. We click OK. Next, let's see what happens if we try to delete level 1. We see a warning that 126 elements and 3 views will be deleted. That is why moving or deleting levels is one of the most critical operations in Revit. We click Cancel. We also click Undo to restore level 2. Now we click on this wall again. We will change the top constraint and select Unconnected. In this case, nothing happened because the wall is attached to the ceiling, so we will first do Detach. For the height, we will enter 700 and click Apply. Now we will select Top Constraint, Roof. Then we will return it to level 2. After that, we will click Attach for the ceiling. Now we will open the north and south elevations. We can see that the extents point is set to 2D, so we will move them like this. So, we know that 2D extents are linked only to a single view. We can see that nothing changed in the other elevation. We can set it so that the change is also applied in the other view, in the following way. We select the levels from which we want to propagate the settings. We click Propagate Extents, and when the window opens, we choose where we want the settings to be applied. In this case, south. Propagate Extents works only between views of the same type, for example, between elevation views. We click OK. Let's check the south elevation, and we see that the settings have been copied. Now we will do Reset to 3D Extents, and then we will copy those settings to the south elevation. Now let's go to the floor plan, select a wall, and draw it here. We return to the north elevation. We select all levels, right-click, and choose the option Maximize 3D Extents. The levels, that is, the starting points of the levels, will move to this wall. This option is used when we want all levels to automatically cover the entire model, which is useful on large projects or after adding new elements. We will delete the wall and move this like this. Now we will return to the floor plan to add a scope box. We go to View, then Scope Box, and we will name it House. The scope box allows us consistent control of the length and position of levels and grids across multiple views. We will draw it like this. We go to the section, and then we will adjust it a bit. Now we will select these 3 levels, and in Properties, we will assign them to the scope box that we just created. A window appears showing an error. So, level 1 is aligned with the scope box. We will extend the scope box below this level and then repeat the procedure. Now it worked. Let's see what happened. When we click on a level, we can see that at the ends we have 2D extents, and at the point where it intersects with the scope box, we can see the 3D extents markers. We can see that when we move the scope box, the levels move with it. The 3D extents remain at the intersection point, but the 2D extents can be moved. Now we will talk about grids. Grids are annotation elements that help organize your design. Grids are key for coordination between architecture, structure, and other disciplines. Creating a framework of grid lines early in the project can help you as you develop your model. To activate the grid, we go to the same place as for levels. So, the Architectural tab and under Datum. Just like in the Structural tab, again Datum. What is different compared to levels is that grids can be drawn in floor plans as well, not only in sections. We will activate the grid in the floor plan. When the tool is active, we see that under Modify, several drawing options are enabled. For now, we will use Line. We draw a line from bottom to top. A second one. A third one. And a fourth one. We are done with the vertical grids. Now we move on to the horizontal ones. Revit automatically numbers each grid. To change the grid number, click the number, enter the new value, and press Enter. The change can also be made through Properties. For the horizontal grids, we will use letters, so they can be distinguished. When we make a change to one grid, all subsequent grid lines update appropriately. Let's add 3 more grids. We can also create an arched grid. Next, we have the multi-segment tool, which means we can create a grid made of multiple segments, for example like this. If, while drawing a grid, we accidentally create it at an angle, we cannot move it by grabbing the end and changing its position. This is solved by clicking on the grid and looking at the angle shown here. We will enter 90 degrees. Another way is by using the Rotate tool. We will delete these 3 grids. Just like with levels, if we select the box, the symbol will appear. When we click on a grid, the distance between 2 grids appears, and we can enter the distance we want. We will set 15,000. Here we will set 1500. Actually, 500. And again, just like with levels, if the symbols overlap, we click on the elbow. We can see how all of this looks in the 3D view. Now, let's go to the east elevation. When we click on one of the grids, we see this blue line appear, which shows that all grids are connected, and we also see the padlock. Just like with levels, if we move one, all of them move. When we click the padlock to unlock it, we can then move that one grid independently of the others. We moved this grid below level 5. When we go to level 5, we see that grid B is not visible. Why? Because it does not intersect level 5. We see that grid B intersects level 4, so let's check level 4. We see that grid B is visible here. We will return the end of the grid so that it aligns with the others. Further, Here as well we have 3D and 2D extents. We will enable 2D for these 3 grids. We will move the grid starts over here. We can see that the 3D extent marker stayed in the same place while we moved the 2D extents. We see that nothing changed in the other views. Also, just like with levels, the view scale affects the display of grids. We can also attach columns to grids. We select a column, and the Move with Grid box needs to be checked when placing columns. When placing third column, we will turn that option off. Now, when we move the grid, we see that these 2 columns move together with the grid, while the 1 column stays in place. We will slightly rearrange these grids. We will also fix this elbow. And, just like with levels, if we want to reset to 3D extents, we select the grids we want, right-click, and choose Reset to 3D extents. We will delete these 3 columns. Now we will check the properties for grids. We select a grid, go to Edit Type, and the Type Properties window opens. We see that the first item is symbol. We will load a new symbol. We go to Insert, Load Family. Again, we go to the Annotations folder. Then to the letter G, Grids. We review the available symbols. We will load hexagon. Now we select the grid again, then Edit. First, we will click Duplicate and name it Grids Example. We will change the symbol to hexagon. Apply. Now we click OK and zoom in a bit. We see that this applies only to 1 grid because the other grids are a different type. Now we will assign this new type to all grids. We select the grid again, then Edit. First, we adjust the view for better visibility. Then we select the grid again and go to Edit once more. The next option is Center Segment. Currently, Continuous is selected. We also have the option None. Apply. Click OK to close the window to better see how it looks. Then we go back to Edit. If we select Custom, we see that additional options appear. We have Center Segment Weight. We will change the line weight to 5. And for the color, we will choose red. For the line pattern, we will select triple dash. Then apply. Next is the end segment, which is this part here. We will set a slightly thicker line so it stands out. 7. Apply. Click OK to close the window, then zoom in a bit so the changes are easier to see while we work. We return again to editing the type properties. We change the color and choose green. OK, then apply. We will choose a different shade of green. Apply. That looks better now. Next, we change the line pattern and select dot. The next item is the length of the end segment. It is currently 25. We will change it to 150. Then apply. We can see how it looks. We click OK to close the window. We can also move the segment manually. Here in the middle we see 2 points, and we can drag them as much as we need. We continue editing. We will set the length to 50. The next item is the symbol at the ends. just like with levels. We check the boxes where we want the symbols to appear in floor plans. We also have this setting that controls how the symbols will appear in other views. First, we will click OK to close properties. Then we go to the east elevation to see this setting. We open properties again. If we select bottom, the symbol will appear only at the bottom. If we select both, it will appear on both ends. And of course none means it will not appear on either end. We will leave both selected. Click OK. We can again adjust these links, just as we showed earlier. Now we go back to the model. We will connect these existing grids again to the existing scope box, house. We see that, just like with levels, at the intersection with the scope box there are 3D markers, while outside of it there are 2D markers. The 2D markers can be moved independently from the 3D markers. And if we turn on level 2, we see that nothing has changed there. Again, if we want to copy the settings to another level, we select the levels from which we want to copy the settings, go to Propagate Extents, and choose the level to which we want to copy them. In this case, level 2. Next, we add a wall. If we want to use the Maximize 3D Extents option, we see that we cannot, it is grayed out. This is because of the scope box. We will exclude these grids from the scope box. Select all grids, click right-click, select the option, and we see that these grids extend to the wall. We will use Undo. Levels and grids are the foundation of every Revit model. If they are set up correctly at the beginning, the model remains stable, flexible, and easy to adapt to changes. Understanding how levels and grids work allows you to control the model instead of fighting it. That is why it is important not only to know how to draw them, but also how they behave, how they affect elements, and how they are used in documentation. We hope this tutorial helps you improve your Revit workflow. If you have any questions, feel free to leave them in comments. Don't forget to like, share, and subscribe for more tutorials.